Assalamualaikum and hi. Our title for this project is Smart Compost Monitoring System, and our group members are me, Rahman, Chang Zijin, Nurul Hanim, Hana Shahira and Michael. Now I will talk about the problem statement for this project. So some of the problems found regarding the current compost monitoring system are: first, school generates significant amounts of food waste every day with leftover rice, noodles and vegetable waste. Although 100% of the school community is aware that food waste can be converted into compost, but they are still remaining dispose it as a general waste instead of recycling it. Second is conventional composting requires frequent manual monitoring of temperatures, humidity and compost levels. This make the process time consuming, unhygienic and inefficient. Third is the lack of real-time monitoring and automation often results in poor compost quality, unpleasant odors and low participation in sustainable waste management.
So I'll have to explain the proposal overview. So the first problem statement: organic waste is often disposed of in landfills, causing environmental pollution and increasing greenhouse gas emission. And then traditional composting requires manual monitoring of temperature and moisture, which can lead to slow decomposing and poor compost quality. Hence, we propose to develop a smart compost bin that use IoT technology, sensors, and automation to optimize the composting process. So the system continuously monitor compost condition and automatically adjust them to maintain an ideal environmental for the composition. And then for the monitoring system, we put temperature sensor that can track compost temperature to ensure effective microbial activity, and then moisture sensor to measure moisture content to prevent the compost from becoming too dry or too wet. And then IoT integration, sensor data are transmitted through an IoT platform to a mobile application or web dashboard, so user can access real-time data and can monitor the compost conditions and receive system updates remotely. And then we expect the outcomes to faster the composition process through optimized composting conditions, higher quality compost with improved nutrient content, reduce manual effort through automation, and increase awareness of environmental sustainability and waste recycling. So we can reduce the amount of organic waste sent to landfills, minimize odor generation and maintain emission, and support sustainable waste management as circular economic practice as environmental impact.
Now, I will explain about the methodology of our smart compost monitoring system, which consists of three main stages. First is the physical sampling or hardware stage. Install three sensors inside the double-layer compost bins, which is the DHT22 sensor to measure the temperature and humidity, the MQ135 sensor to detect the gas levels, and the ultrasonic sensor to monitor the compost level. These sensors continuously collect the real-time environmental data. Secondly, it is the processing and actuations. The sensor readings are sent to the ESP32, where the program developed using the Arduino IDE processes data. If the temperature or humidity exceeds the preset threshold, the ESP32 activates the relay module to switch on the ventilation fan, helping to maintain suitable composting conditions. Finally, it is the cloud and user interface. The ESP32 transmits all the real-time data through the Wi-Fi to the Blynk mobile applications, allowing the users to monitor the compost temperature, humidity, and gas levels remotely and conveniently.
Alright, moving on, we will show you our brief video of our prototype development.
Now, I'd like to show the IoT development and integrations of our smart compost monitoring system using the ESP32, Arduino IDE, and the Blynk mobile applications. On the left side, it is the Blynk app interface, which allows users to monitor the compost bin remotely in real time. It displays the important parameters such as temperature, humidity, carbon dioxide concentrations, and the bin fill level. The app also shows the status of the actuators, such as the DC fans, and allow the user to manually override the automatic control if needed. In the middle and on the right are the Arduino IDE codes. These codes process the sensor readings, compare them with the predefined threshold values, and automatically control the relay module to activate the devices like the ventilation fans, and at the same time, the ESP32 sends all the sensor data to the Blynk platform through the Wi-Fi, ensuring that users receive a continuous updates on their smartphones. These integrations enables a real-time monitoring, automatic control, and remote access, making the composting process more efficient and user-friendly. Moving on to the real-time monitoring results of our smart compost monitoring systems. On the first slide, the graph shows the temperature and humidity trends throughout the monitoring periods. The temperature remains relatively stable at around 22 to 24 degrees Celsius, while the humidity fluctuated between 45% and 55%, which are suitable conditions for composting. These results demonstrate that our system can continuously monitor the compost environment and automatically maintain the optimal conditions through a real-time sensing and control. On the second slide, the graph shows the carbon dioxide concentrations inside the compost bin over the time. We can observe that the carbon dioxide level gradually increases during the active decomposition process, reaching above 3000 ppm before decreasing and stabilizing around the threshold level. This indicates that the ventilation system successfully reduced the gas concentrations when it became too high. The table on the left summarizes the readings, showing that most measurements were within the elevated and high categories, while no hazardous level above 5000 ppm were recorded.
Moving on to the next section, let's take a detailed look at the product costing. On this slide, you will see a complete breakdown of the expenses of all the materials and equipment implemented in our program. Our main controller, the ESP32, is our highest individual cost at RM31.35. For the environmental monitoring, we integrated an MQ135 gas sensor for RM8.20, and a DHT22 moisture and temperature sensor is for RM7.08. To manage the electronics, we include a 4-channel relay module at RM50.40. For the physical hardware, we use a double-layered compost bin and an inner layered metal bin costing RM19.80 and RM20 respectively. Finally, a DC fan was added for ventilation at RM12.50. Bringing it all together, the total cost to build the system comes out at exactly RM112.33. This demonstrates that our prototype is not only highly functional but also remarkably cost-effective to produce.
Now, I'm going to present a survey analysis conducted before and after our outreach exhibitions involving 40 primary school students. Before the activity, the results showed that awareness of composting was relatively low. Only 4% of students said they knew a lot about composting, while 32% had no knowledge at all. In addition, 64% of them had never seen a compost bin before. However, most students already believe that the food waste can be turned into something useful and the technology can help reduce the food waste. After the exhibitions, the results show a significant improvement. 88% of students understood what composting is, and 92% of them understood the importance of reducing the food waste. Most students also correctly identified the fruit peels and kitchen leftover as compostable materials, and almost all recognized that our smart monitoring system monitors temperature, humidity, and gas levels. Overall, this finding demonstrates that our outreach activities successfully increased the student knowledge and awareness of composting and smart waste management.
Alright, so for the reflection, this project has been a meaningful learning experience for our team. Through the development of the IoT-based smart compost system, we were able to apply our engineering knowledge while improving our technical, communication, and problem-solving skills. Besides the technical aspect, we also had the opportunity to engage with the community through our outreach program at SK Jalan 3. We introduced students to sustainable waste management and composting while demonstrating how engineering and technology can be used to solve environmental challenges. So overall, this project created a positive social impact by increasing awareness of environmental sustainability and encouraging students to adopt more sustainable practices in their daily life. It reinforced our understanding that engineers have an important responsibility to develop innovative technologies that improve quality of life while protecting the environment for future generations. To wrap up our project, we are really happy that we successfully developed our IoT-based smart compost monitoring system. Throughout this project, we integrated different sensors with the Blynk app, allowing users to monitor the compost condition, including temperature, humidity, gas concentration, and compost level in real time. This makes the composting process more efficient, convenient, and user-friendly. Beyond developing the technology, one of the most rewarding parts of this project was our outreach program with primary school students. It gave us the opportunity to share the importance of composting and environmental sustainability while encouraging them to practice green habits in their daily life. So overall, this project shows how engineering can provide practical solutions that benefit both people and the environment while supporting the sustainable development goals. Thank you.